Um, let's just get started here. I know we started a little bit late. Just a fair warning before we really get started today. Um, Today's session might go a little bit over an hour. It just depends how quick we end up going pacing. But since there's like a live code demo, we might end up going a little bit over that hour mark. So just expect that, and feel free to leave if you need to. Um, But just want to warn you guys before we get started. But yeah, so thank you guys so much for making it in person, and to the people watching the recorded video after, thank you for watching this. But this is going to be Road to AI Data Day 1. So this is going to kickstart our workshop program for this whole week, where we're going to have a workshop every single day leading up to the Datathon this Saturday. And that being said, even if you didn't get admitted to the Datathon, people are still, open to watch this. Um, and I would even recommend doing so if you're interested with the topics at hand. But anyways, without further ado, let me just start talking about what we're gonna go over today. So, day one is gonna be all about exploring your data. And I think I said this in previous workshops, and I kind of re want to reiterate it again. How I think this is one of the most important steps to the data science pipeline, and like this is you really want to be good at doing a EDA and basically getting a good understanding of your data. Um, I would say just today, just make sure you try to pay attention and follow along, especially if you are joining us live over the Zoom, or even if you're somebody watching the recording right now. I would definitely just get like well, I'm gonna show you guys what to do to set up right now. But set up with us and just like code line by line with me, and I think there's gonna be a lot that you can learn from this, and a lot that's gonna be actually applicable to what we're gonna do at the Datathon. Um, so yeah, without further ado, we're not really gonna be going over a PowerPoint today. Actually, I just wanted like this title slide, just so you guys have something to look at while I'm talking right now. But today is all going to be just a walkthrough of how to explore your data. And we're going to be using Python pandas, and we're actually going to be starting with Kaggle. So if you guys could, hopefully you have me set up somewhere else, or like maybe on like another screen or something. I want you guys to open up Kaggle on your desktops. Um, and if you can't, be coding, it's okay. Just follow along and just watch, the video today or the walkthrough today. But as you can see, this is all I had. I want you guys to open up Kaggle, okay? So from Kaggle, I'm gonna show you guys how to get started with the notebook. Hopefully, you guys have already made accounts. If not, please do. But we're gonna be using Kaggle today for our exploratory data analysis, and I would say get used to using Kaggle, because for the Datathon, this is the website we're gonna be using. So I think this is the perfect time to really jump in. So from this home screen, if you once you're here, click on this create button and click new notebook, right? And then it should start, it's just gonna start loading up your environment. You should get some like starter code that looks like this. Um, and I would just go ahead and delete this. And feel free to name your notebook. You can name it whatever you want. I'm just gonna keep mine default for now because I'm actually not gonna use this notebook, but I do want to show you guys how to get set up. Because today we're going to be importing a data set from Kaggle. So let me just give you guys a quick description of what Kaggle was. I didn't really explain it at the start, but Kaggle is basically this website um, where there's a ton of data sets and notebooks on there. Kaggle is by Google. I feel like that might be important to note. But there's like a bunch of data sets on Kaggle. A lot of them are already pretty cleaned through, and it ranges from a lot of different topics. There's also data competitions on Kaggle, as you guys could see on this left side. I guess they have hosted models. I've never even checked out that page before, and you could also run your own code on Kaggle. But today we're going to be taking advantage of running our own code on Kaggle and checking out some of Kaggle's data sets. Um, so once you guys have are at this notebook page, I actually want you to go to open up a separate tab. really quickly. Uh, Another Kaggle tab. And then once you're here, I want to search up exam scores. Once you search up exam scores, you should see one of the top data sets is student exam scores, an extended data set, as you guys can see right here. And so this is the data set that we're going to be using today. Um, and I'm going to talk a little bit more about the data set, but basically we're going to be doing our whole exploratory data analysis on this data set. So I'm not going to go over it too much right now, because we're going to be able to, understand what the data set has to offer as we go through. Um, but right here, student exam scores extended data set by Des. That's the user's name, updated 2 years ago. And so the way that we're going to want to import this data set today is I want you guys to hit this download button, and then you should see download via Kaggle Hub. I want you to copy this. I'm going to copy it and paste it inside of your notebook. It should be like the first line in your notebook. Um, and so yeah, just do that really quickly. Here again is what the data set looks like for the people watching right now. Um, it's student exam scores extended data set by Des. So actually, I have a separate notebook that I'm going to go off of that's a little bit more annotated, but I wanted to make sure to get this setup part with you guys going um, because this is pretty important. And so I actually have this over here. So I'm gonna print that statement down here, and I'm just gonna run it real quick. So the way you run a notebook cell, I'm not sure if you guys are too familiar. I'm just gonna try to lead you guys through what's happening today pretty slowly, but I'm gonna expect some level of experience with Jupyter notebooks and these types of environments already. So I want you guys to run this cell. You could either press this button. I usually just hit Shift Enter though. And then you should see this running icon and then it should run. And then once that is finished running, you should see this data set in inputs, right? And then so what we're going to want to do here is open up this data set and we're going to want to copy this file path to expanded data with more features, right? Um, and just for the time being, I'm just gonna say, call this data, uh, sorry, data file path is equal to this, and then paste that, um, file link, or like the file link, the file path. That's like the initial setup. From there, we're almost ready to just start working with the data set, but I just want to make sure you guys have that, setup all clear. So. I guess I'll get I feel like that was kind of like the preliminary in my head. So now I'm just gonna tell you guys about a little bit what we're gonna do today. So we're gonna be doing an exploratory data analysis. As I've said a couple times, and I think we might. Can you go over? Oh, okay. Okay. How do we get the data file again? So here real quickly, let me show you. So you're going to want to go to student exam scores, extended data set, go to download, and then you should see this download via Kaggle Hub thing pop up. And under that, you're going to want to copy this code and then go over to your notebook and paste your code and then run the cell. And once you run the cell, this data set and inputs should pop up. If you don't see this notebook, go to view, and then it should just be view sidebar if it's not there right now. So just go to show sidebar and then that data set should pop up. Hopefully that helps. But okay, that's kind of like the preliminary setting up stage. Now we're really just gonna be going through the notebook together. I actually want to get rid of this left sidebar hide toolbar. Go to how do I get rid of this left sidebar? It's fine. It's honestly fine. Okay, so we're going to be going through an exploratory data analysis, and I think I've explained this in previous workshops already, but just really quickly, the whole idea of an exploratory data analysis is to be going through a data set and exploring your data and gaining insights from your data without running it through a model yet. And a lot of the time, you want to gain these insights so that we could put the data into a model effectively and we actually know what we're doing with the data set. And so it's like a really instrumental step in the data science pipeline. And um, I would say it's about like 80% of the work, um, because it includes steps like pre-processing, cleaning the data, and I would say one thing that we're not going to do today, but prepare the data for the model is another part of an exploratory data analysis. But that's more so when you're doing it to cater for a machine learning model. This one's more to just understand the data set. But okay, without further ado, I think I'm just gonna get started. So. Um, First I want to say I want to give my flowers to this video right here. And I have this link I'll go to real quick. But this guy, Rob Mula, Exploratory Data Analysis with Pandas Python, was a huge inspiration for today's notebook. And I wanted to shout that out really quickly because if you watch that video, you're probably going to see a lot of similar stuff. He uses a completely different data set, and I did add more. But if you're interested, definitely check this guy out. Anyways, so step zero, importing and reading the data. So we already kind of got like the importing the data down. And so at the top here, um, I'm gonna add the libraries that we're gonna be working with today. So let's get started. All right, so the first one is we're gonna import pandas. And if you're not too familiar with the ecosystem of these libraries, usually we import it as PED just to make things easier when we're actually coding. We're also gonna be importing NumPy as NP. And these are little like short names for when we do start using the libraries. It'll make it a lot easier basically. So don't worry about it too much. But basically, we're using pandas, NumPy, and then we're also going to be importing matplot, oops, plotlib dot pylab as PLT. And this is going to be for a lot of the visualizations that we use today. And another important visualization library that we're going to be using today is seaborn, and we're going to import that as SNS. Um, and that's gonna be it for now. So go ahead, and run that. Um, it should run successfully. You've already ran this, right? So we don't have to run it again, but you could, and it's gonna tell you where the file path is. And then hopefully, if you haven't already, again, we want to copy this file path and put it into a variable called data file path. Because what we're gonna do right now actually is load that into a pandas data frame. So um, again, I'm not gonna hold your hand too much. I'm gonna assume that you guys are somewhat familiar with pandas, and if not, you're gonna learn a lot of things today. So don't worry about it. But I'm not gonna explain what like a data frame is, or anything like that too in depth. Just like really quickly, I'll just say it's what pandas uses when it stores like tables and data, and that's what we're gonna be modifying and like reading today. Um, so as you see, we have this file path to our CSV of extended data with more features, right? And so the first thing we're going to do is we're going to go df is equal to pd.read CSV. So this is a pandas read CSV function. And then we're going to put in that data file path. And then we're going to go ahead and run that. Oops. Uh-oh, something went wrong. Let's see what happened. No such file and directory. Uh-oh, what do you mean? Give me 1 second. How come? Sorry, give me 1 second. Oh, that should that should be working. Hold up. No such file and directory. How come? Kaggle input. Maybe add input? Okay, let me do that real quick and then add it back. Sorry about that, guys. And copy file path. Anyone able to load this right away that's here right now? Or is anybody else having trouble? I think this is actually working now. That was pretty weird. Um, I don't understand why that didn't work originally, but I think that ran now. Oh, okay. Let me run this stuff again. No, now it's having some troubles. Sorry, guys. Give me 1 second, actually. I want to make sure I have everything right here. Examples. Anybody in the chat trying to run this code and having any issues, or are you guys able to run it cleanly? Wow, I'm actually so confused. Why isn't this running right now? I just tested this like a second ago and it was running. What? Oops. Can't run it? Okay. So there's an alternative that we could do to this, but I didn't really see this coming. But maybe you know what? It might be for the best that um I show this part, even though this should run pretty smoothly. I don't know. Did I do something wrong? No. Okay. Well, I guess as a backup, I didn't expect this to happen, but as a backup, you could also download the dataset as a zip. I'm gonna do that really quickly. It's a pretty small dataset, so it downloads like instantly. Um, and then so I'm gonna open that actually on my current file system. And then I'm gonna import. Let me close this. Import it into the notebook. Um, I don't really understand why. But I'm gonna upload new dataset, and then I'm gonna drag and drop this really quickly. Sorry about that, guys. Let me make sure this is working out though. Okay. Files, visibility, enter dataset public. The testing. Sure. Great. So you guys can follow along and do this. Okay. Continue. It says it already exists, but it won't read from it. So I'm gonna let it create that really quickly. Okay. Done. Closed. Um, and so we have this testing data set now. Okay. Now let me copy this file path and then put it inside of this read CSV, and hopefully that works. I see something like that. Mine is running. Yeah, it should be running pretty smoothly. I never had this problem with Kaggle before. Import you might be missing import pandas as PD. No. Okay, or let's run those cells again. Okay, mine just ran. That was really weird. Um, I don't really even have an explanation for why it messed up like that. Uh, so that was kind of weird. Hopefully your guys' is running. Mine just worked after putting the data or downloading the data set and putting it on Kaggle myself. Well, let me try copying this path again. Is it having trouble reading from this path? Uh, Sorry, this is a little bit of a delay, some technical difficulties, but this is pretty important, so I just want to make sure it's works. Okay, so now that works as well. I'm confused. But anyways, um, it works for me now. Maybe I just need to there's a problem with my notebook and I had to reset it or something there. That was pretty weird. But now both of these work. So I don't really understand, but basically there we're just doing the read CSV function that Pandas has, and we're giving the file path to the CSV. You still can't run it. Did you try um downloading the zip and then going over here, upload new data set, and then downloading or uploading the this file from the zip? If not, that's what worked for me. Um, and if I would also say do a factory reset or something, like do this button. I didn't try that initially. Um, but try that. Anyways, that was pretty weird, I won't lie. But it's okay. We could get going from there. That should hopefully be the only hiccup we have today. Okay, so let me hide the sidebar. So I would recommend doing that. Um, just try to get this loaded. As long as this cell runs, that's all that matters. Um, and so let's really get started now, okay? Hopefully you guys got the data set loaded. And the first thing that you should do whenever you have a data set is do df.head. And that is gonna give you what your data set looks like right here. So as you guys can see, we have this data set of, or it's, so actually df.head, um, first of all, I should probably explain the naming convention a little bit. DF stands for like data frame. And so whenever we do a read CSV function, it gets loaded into data frame. So this is now a data frame object, and dot head will output the first five, um, like the first five rows of the data set. And in this data set, actually, you get to see all of the data. But there are some scenarios where, say, I think if you have like more than 15 different columns or features in a data set, it the df.head won't show all of them. And there's one thing that you could actually do, and I just wanted to add this here. It's not really needed for ours, but I think it's pretty important. If you do pd set options display dot max columns to 200. Basically, this will now, like whenever you do df.head or any other displaying thing that pandas has to offer, it will now show all of them instead of cutting it off a little bit earlier. It's just a little quality of life change. So I'm just gonna run that cell again. Um, wait, what? What's going on? What's going on? Now display max columns doesn't exist. Set options. Oh, it's set option. Okay, okay. I thought I was going crazy. There we go. Set option. Uh, we're all over the place. But anyways, I just want to get the throw that out there. I think it'll be useful for future projects that you guys have, and I would definitely add this to the top of your imports whenever you are starting a new notebook and a new data set. It definitely makes it a lot easier to read. In this scenario, we could actually read everything pretty fine, so it's not too relevant. But yeah, so now that we see the first like five rows, we can see the different features that we have in this data set. So um, this data set is going to be filled with student exam data, right? So it'll these are all individual students. And then it's going to give us a math score, a reading score, and writing score for every single student, and different qualities from each student, like how they transport to school, are they a first child, how many siblings they have, their parents' marital status, et cetera, et cetera. Um, and so this is all pretty, I would say, interesting data and data that could be relevant in predicting like an exam score. So that's one thing that we could start thinking about right now. Um, but I think first things first, let's not jump into any conclusions. I would say step number one is to try to understand the data. And one of the most important things you should do whenever you load a new data frame, actually, other than df.head, is actually df.shape. So when we run that, we can see the different qualities of our data set. We could see that it has 30,000 rows and 15 columns. So these are going to be 15 different features and 30,000 different individual students or rows. I want maybe not individual students, say if there's duplicate data there. But that gives you a pretty good idea of what the data set actually looks like. So I want to make sure you guys know about that. And then there's also other things you can do with df.head. Df.head originally prints out the first five, but you could actually choose how many you want to print out. So if you do df.head 3, it'll print out the first three. Df.head 10, it'll print out the first 10. Ignore this error. It's just Python 10 and the Kaggle notebook, but it'll print out the first 10, etc., etc. So you guys can play around with that if you'd like. And there's also a df.tail method, and this, if you probably couldn't guess or could guess, df.tail is going to print out the last five feet or rows of the data set. So as you can see here, here's the index on the left side, and um, and they're um, sorry. And they're different features. And you could also do the same thing with df.tail, where you could do like you want to see the last 10, you can see it there. So I thought I'd share that with you guys, and it's pretty important. So another thing that you could do when viewing your data set is say like, okay, maybe the first five or first 10 or the last 10 kind of have biased data, or maybe don't give a good um, picture of the whole data set. And a lot of the time this is pretty like a pretty decent guess that this would happen because um, usually when data sets are getting inputted with information, they like to do it in a certain order. So maybe the first 10 of the data set are all specifically students from from a specific school or something. So if you want like a more diverse look at the data, I would go df.sample and you can do any number. If you do no number, it's just going to do a random index sample. But if you do like 5, it'll sample 5 random rows in the data set. So that's something that I personally like to do when I'm looking at my data. I don't like to just look at the first 10 or 5. I like to do dot sample, and I feel like it gives me a better understanding of like the diversity behind the data set. So I just want to throw that out there. And another important thing to look at is here we could kind of see all the different columns that our data set has. But a better way to look at it, and one that we're going to be running a lot today, is df.columns. So here it'll list you all of the columns in the data set. And this is very useful, especially when you don't want to have to keep on running df.sample and then like looking at all of these specifically. It's just all there in one big pile. And we're going to be running that a lot today because it's actually easier to modify data and copy it from this list as opposed to going um, feature by feature in this table. And one of the other things that I like to do when I'm looking at a new data set is df.dtypes. Um, and this basically gives you the list of all of the features in the data set as well as what their variable types are. So for example, this unnamed zero, which this is kind of weird, and we're gonna get to it in a second. I don't even know what this is, but this is an integer. These objects mean strings. Um, and then we have a float, which is like a decimal point number. And then we have more integers down here when it comes to the reading scores. So this will tell you what all of the data types are for your data frame. And it's important to look at this, especially because there's going to be some times where data types are kind of inconsistent and don't really make sense. Like, for example, say reading score was an object instead of an integer, we would have to change that because we want it to be represented in the correct way. And we're actually going to get more into that in a second here. But I just wanted to mention that now. And one of the last things I like to do when just trying to understand my data is doing df.describe. And what this does is it takes all the numerical data in your data set and it gives you like I would say a rundown of each of these important parts of it. Uh, for example, the mean, the standard deviation, the maximum, the minimum, um, for each part of the data set. So, and it's only for the numerical data. I want to mention that. And so, yeah, that about sums up trying to understand the data set. And now it's time to really trying to prepare the data. So now we kind of see the different parts here. And this is like around the time to start having a conversation about what these different variables possibly mean, especially if they're not labeled really nicely. Like for example, unnamed zero. I have no idea what that is. Um, and so we're gonna have to do some data preparation now for our data frame to do things to those specific features. Um, so I just want to do this again. Just df.head so we have it down here just to show. And then this, I mentioned it a couple times already. I don't really know what unnamed zero is, and I'll be honest, I don't think it says on the Kaggle data set description on what it is. Maybe it's an important feature, but for right now, it just looks like another index. So I think I kind of want to drop that. Um, and so I'm going to show you guys how to drop columns. Also, I didn't go down these bullet points, but in data preparation, we're going to be doing stuff like dropping irrelevant columns and rows, identifying duplicate columns, renaming columns, and then creating new features. So this first part, we're going to want to be dropping unnecessary columns. So let me do df.columns again so we can see all of the column names out in the open. And so one way you could drop columns, and especially if you don't have a lot of columns you want to drop at the same time, I would recommend doing it this way, is do df dot drop, and you're going to do columns is equal to a list, and this list is going to have the different column names that you want. So actually, I could just take this from df.columns and copy and paste that into there. Let me do that really quickly. Um, And then one thing that we're going to want to run, and I'm going to explain this more once we get there, but we're going to want to have in place is equal to true. Because if we don't have in place equal to true, it's actually not going to modify the data set. It's going to just think it's a reference. But now that we have in place is equal to true, it's going to like refresh and the column will actually be dropped. So let me do that really quickly. And after you run that, you could do df.columns. And as you can see, there's no more unnamed zero in the data set. Um, so that's one way you could drop specific columns, but actually there's another way. So and I would say that this is like a better way to do it if you want to drop multiple. Say that in our data set right now, I see a lot of these features and I only want to work with a couple of them. Um, and so um the one way to kind of do that is you go in, you go df, and then you do double brackets, and you copy all of this from df.columns, and you paste it. And from here, what you could start doing is commenting out um, the columns you don't want. And so, for example, say I don't really care about the gender or ethnic group or parent education, so we keep those out, but I'll keep the lunch type and test prep. I don't really care about the parent marital status, but I want to keep like the practice sport, first child, number of siblings. Um, I don't really care about the transportation means, so let me comment that out. And but I do want to keep like the weekly study hours and the test scores um, that are actually there. And so this is one really, really useful way to kind of just like go through the data set and clean up the stuff you don't want to do. Um, oh, sorry, I just got a message in the chat. Kelly says df.drop columns is equal to unnamed zero isn't working for me. Uh, did you unnamed zero? It should work. It should run. If it looks like this, if you try running it multiple times, after the first time the column isn't there anymore. But if this is working and then you do df.columns and the column name is still there, then that is a problem. Here, let me just paste this exact thing in the chat to try to help you out there. Um, and then try pasting that in your code and hopefully it works. Um, right now, just looking at what you sent, I don't see if there's any errors. But I would say that to also like make sure that specific column names are read, because like for example, if this was a under undercase, lowercase u, it would not know this is the specific column name. That's why I really do think that if you're gonna be doing stuff and modifying columns, doing df.columns and then copying pasting is the best way to go, just to try to avoid those types of errors. Um, so yeah, just try that out. It's still not working. It's okay. If it's not working, you could skip over it, but I would definitely check that out after it's over. Um, I don't understand why it wouldn't be working. But anyways, we could talk about it after the session. But well, when we're purging different columns, this is one of the best ways to do it. And to save this as a new data set or data frame, we could do df is equal to what we have here, and we do dot copy in parentheses. Um, and if I run this, um, and then do df.columns, you guys can see that it's only the stuff we kept now that's inside of our data frame, which is super cool. And the reason that we do dot copy right here, I want to mention, is that instead of Python's going to assume that we're just referencing this, and that could lead to weird errors. Like in this scenario specifically, actually, it would be fine. But like, say or d what dot copy does is basically copies the data frame that it sees before it like puts it into a new variable. It's just a good way to make sure everything's like going through smoothly. I just want to mention that right now. But in this scenario, actually, I don't even think dot copy is needed, and it would still be updated. Um, but I just want to mention that. And so, as you guys can see, um, with the do df.columns, here are all of our new columns. And if I do df.dtypes, you guys could see it's all there, all still there. And so now the next part I kind of want to look into is that this number siblings, um, this number siblings feature is a floating point, and that doesn't really make sense because that means that there could be decimals to a number of siblings, and I don't think you could have like 2.5 siblings or like 3.1 siblings. Usually it's integers, so we want to try to change that. Um, and so you could even see if you do df and then do take this number siblings right here and put it in there and run that really quickly. That they're floating points instead of integers. So we wanna change this over to an integer. We don't want it to be like that because that might just make some weird stuff when we end up running it later on, in like a model or something. So the way that we would change that actually is we would take df, and I'm just gonna copy and paste this just for simplicity, is equal to df number siblings is equal to df number siblings, but do dot as type int, right? And then if I run this, whoa, I get an error. I actually expected this error. This has been another mess up. Why do we get this error though? So if we go down this huge stack trace, cannot convert non-finite values, NA or infinity to integer. So that means there's either NA or infinities in number siblings, right? And so how can we check that? So one way we could do is df.isNA, and this is going to give you a true or false for every variable type, whether the inserted value is NA or like does not exist or unnamed or if it's NA, it'll give you true, but if it's not, it'll be false. Um, and a better way to visualize this actually, because this is just a bunch of like falses, you're not really going to be looking through that and making much sense of it. Actually, we see true here, so you can see that this is an NA value. But do dot sum, right? And so what this is going to do is it's going to tell you how many NAs or missing values are for everything in all the variables in the data frame, or the features. And so you can see test prep has a lot of missing values. Um, Practice sport has a couple. Um, there's 904 is first child, and as you can see, we got our error for number siblings because there's around 1,500 um, missing values for number siblings. So now the question is, okay, well, I still want to change it into an integer data type, even though um, there's like these missing values. Like, so how would I do that? So there's two things that we could really do. Um, and actually, wait, before we get continued with that, I actually there's a better way to visualize this specifically for number siblings. So if I go to number siblings, you could do is NA just for the column. And this again outputs that false true list. But it's, if we do dot sum, it'll tell us how many um, NAs there are inside of this. I'm gonna say missing values. I keep on saying NAs, it keeps on tripping me up. How many missing values there are in this column? And there's actually a cool way to visualize that. If you go like this really quickly, just wrap this inside some brackets and then throw another df on the outside. And now when I run this, this is gonna, if just ignore this output, this is going to show us all of the places where the number of siblings is a missing value. So all I did there was just do the df is NA inside of another bracket and then put df on the outside. And basically it's indexing all the places where this is true and it's outputting that to us. And as you can see, all these missing values where number of siblings are. So that's another cool way to visualize it, and you get specific indexes when you do that, and you know the specific rows. So I just want to do that really quickly. But basically, there's two things that we can do. Um, oh, sorry. I just saw something in chat. Can we go back to df is equal to df? I didn't finish copying. Oh, yeah, sorry. That was a little bit ago, I know. But basically, what we did here is we just copied the columns, right? And then we pasted them in here, and then we took out the gender, ethnic group, parent education, parent marital status, and transport means. Um, and I'll leave it here just for a second, just so you can see. Um, but yeah, if you want to follow along, I would definitely make sure that you have this right because we're going to be looking at specific var or features in the data set later on, and so this is pretty important that you get this stuff down. So it's just these five that are missing, and again, you'll probably see which ones are included whenever we do df.column. So you could always go back and drop them if you missed any. But anyways, um, there's two things that we could really do to number siblings, the missing values in number siblings. We could either drop all of the missing or the rows that have missing values in number of siblings, or we could put new values within these missing values to basically fill them and make sure there's no missing values. And this is a pretty important concept when it comes to data pre-processing and data cleaning is what to do with missing values. Um, and so today actually, my plan is to drop all of the rows, but I am going to show you what code you would do if you did want to fill these. Um, and so the way that you would fill it is you would do df.fill_na, right? And also, I wanted to point out that the ninth index here is has a missing value, so I'm gonna point that out a couple times. But you do df.fill_na and then you would fill it with whatever value you wanted. So you could do stuff like the mean of the number of siblings. But like for example, let's just assume that everybody that is like missing a value for number of siblings doesn't have any. That assumption would actually be wrong. I want to point out because you can see here is first child no. So this person has to have siblings if he's not a first child. Um, and so some of these are just errors in the data frame that just were never inputted. But anyways, so we would do it with df.fillna0, and then we're gonna do dot head 10 because that's how we're gonna see this ninth index. And we can actually run this. Um, as you can see, with this ninth index now has number of siblings 0, and I can assure you that all values were filled, all missing values were filled with 0. But actually, I wanted to also point out that this didn't actually modify our data frame. So if I go to df.head again, 10, just raw, this is still a missing value. So that is one thing that's kind of confusing when it comes to working with data frames is basically how they save. There's two ways to save data frames. There's you could do reassign it to itself. So something like this would make basically the new data frame this reference. Um, or I think with fill NA specifically, you could do, and a lot of the pandas functions, you could do in place is equal to true, and this would and then you don't have to do this anymore. And in place is equal to true basically makes sure that we are refreshing the current data frame. Wanted to point that out as well. But anyways, we're actually not going to be wanting to fill the missing values today. So I just wanted to show that as the way. What we're gonna want to do is be dropping the rows with the missing values. And so let me do that really quickly. And so the way that we would do that, there's actually kind of a cool way to do it. One of the ways is, and I'll do this down here in this new cell, is going to be df is equal to df.drop na, right? So drop na, just kind of like fill in na, but now we're dropping them. But you're gonna have to do a subset, because if you drop na straight up, then it's gonna drop all rows with any missing values. But what we're gonna want is a subset, and in that subset, we're gonna be including our number siblings um, column name. And so this is now it's just only going to check number siblings and drop any missing or rows with missing values in number of siblings. So this is one way to do it, and actually I'm not going to run that. I'm just going to comment it out. But the way that I'm going to do it today is this way. So there's this thing called df.log. And again, I feel like I might be going a little bit too slow trying to explain what everything in pandas is. But basically, this gets you like the location or the index for some specific, um, oh whatever you put on the inside. So this is a pretty cool way to do it. So basically, you do df.log df number siblings, and then dot not na. And so what this is basically going to do is it's going to give us a new data frame of the location of all of the number of siblings that aren't NA, and not basically if any of them are missing, it's not going to include them. Um, and so df.loc will give us that new data frame, and then we could reassign it going like df is equal to df.loc. And now if you run that, that should work. And so I would say to check to make sure that worked, we're gonna do df dot or df number siblings. Or sorry, I should just copy this actually. Hold up, copy this really quickly. And dot is na dot sum. And then as you can see now, we have no more missing values for number of siblings, or any rows with the missing values for number of siblings. So that clearly worked. So that's one cool way to do it. And now that we have no more missing values, or if you guys remembered, our original plan was to actually turn number of siblings into a integer instead of this weird floating point that it currently is. So we're gonna go up really quickly to where we had that. So this was the code for it. And I'm gonna paste it again down here. Um, and I'm just gonna keep this so you guys can see. And so if we run this now, there's no more errors. And now if we do a quick df.head and scroll down, now all of our number of siblings are now integers. So that was a lot of work, as you can see, but that also showed a couple cool things that you can do with pandas when you're cleaning your data, um, as in what to do with missing values, and how to change data types. And there's two important data type like or ways to change into different data types that I kind of want to point out, and I have them right here actually. So PD dot to data time with like a date value. Um, is really useful for when you want to turn because a lot of the times in data frames, in this one we don't have any examples of that, and so that's why I'm not doing it. But there will be dates that will be logged as string values, and so this to date time will turn them into a date time value or like a timestamp, which is better when you're running it through a model, and you're able to do more stuff with that. So this is a pretty important one, and another pretty important one is to numeric. It's just like what kind of like what it sounds like. Say, for example, it was logging all of these math scores as um, strings and not integers. This would basically change them to integers or floating points, even if it was in like a decimal, but it was a string. So to numeric is another important one. I just wanted to point those out really quickly because we're not going to be having any examples with that. Um, and so yeah. So if we do, here, can I clear these? Or actually, I'll just start from down here. So if we do df head dot 10, right? And if you guys remember from earlier, number 9 was had a missing value. If we go df10, now 9 is missing. And so it worked. But now the index on this left side is messed up because now it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. It skips 9 and it'll also skip any indexes that were also deleted. So we want to try to fix that. And this is the main way to do it. If we do df dot reset index, this is the function that we'll be running. But I've showed you guys before, you can't just run something and um I cannot explain. Expect the data frame to save that. You're gonna want to have to do it like as a reassignment like this, or actually the correct way to do it is gonna be um or actually yeah. Doing it like this is correct. And so let me do that really quickly, right? And now if we do df.head 10, Um, now you can see the index reset worked, but now we have this weird index column. And we don't want that index column because now it has all the old indexes. So again, we're just gonna go back and drop that. Um, but actually, there's a way to do this cleaner, and I probably should have just skipped this way so we don't have to go through this whole all this work of dropping index. And I'll just do this df.drop columns is equal to. This is a code from earlier, so you guys should remember what this does. We do index, and then we do um, in place is equal to true. And so now that should work. And then if I do df dot head 10, as you can see, the index column is now gone. But if you don't want to do these like multiple steps, like I just did right there, there's actually a better way to do it. Instead of doing df.resetIndex, what you could have here is drop is equal to true, and then do dot copy. And what this will basically do is it'll make sure to drop this index column before it copies it. And then so you won't have to go through dropping the columns manually yourselves. Um, so I just want to throw that out there. Okay. And so now we're going to go over renaming some columns. And honestly, if you take a good look at the ver or the names that we have here, they're pretty good. They're pretty intuitive. You could understand what a lot of them are. But there's gonna be a lot of data sets that you guys work with where it won't be as intuitive. And so that'll be specifically for those types of scenarios. You're gonna want to rename them to make sure all the names follow like a certain format. Um, it's just a lot easier to view from an outside person's perspective. So let me show you guys how to do that really quickly. So if I go, I'm just gonna delete this and do df.columns real quick. As you can see, here are all the column names. And so the way that we rename columns is we're gonna df.rename. And then we're gonna do columns is equal to, and instead of a list, we're gonna be doing these brackets for a dictionary, which is kind of weird. And um, this is all going to make sense in a second. But the reason we do a dictionary is because we take in the old name. And so th for this example, I'm just going to change number siblings and weekly study hours to not have like these indentations or like the shortened format. So we take the old name of the column and then we do a colon and then we do the new name that you want. So here I want number siblings written out. And then you can do this for multiple columns with a comma. And then I'm going to do weekly study hours. And then we'll change that. And then I want that to be weekly study hours, right? And again, like I've said multiple times, this isn't going to save it right away for some reason. So what we're going to want to do after that dictionary is do in place is equal to true, and that'll save the data frame in place. Okay? And so now if we do df.columns, you guys should see the new column names. We have weekly study hours and number of siblings all spelled out. So that's how you rename your columns. And so now I'm going to show you guys how to look for duplicates. So this is the way you generally check for duplicates is df the location of all of df.duplicated right here. And if I run this really quickly, this will show you all of the rows that are duplicated in this data set. The thing with our current data set and why this might not be too relevant to us is because we don't have like an identifier for the student. So any any student with the same scores and same habits as another student is going to be detected as a duplicate, even though that is all still technically possible. But there's no way for us to determine whether those two students are actually two different students or two duplicates. So in the scenario of our data set, it actually doesn't really make sense to be dropping duplicates. But I will show you guys how to do that anyways, because there will be some scenarios in future data sets that you guys see where you're going to want to drop duplicates. And so let me show that. But actually, so this df.duplicated is going to show basically where any row is where all of the types are matching with some other row in the data set. But if you want to see, for example, all of the students with duplicated like math, reading, and writing scores, there's a better way to do that. And so let me do that real quickly. And so we do df lock and then df.duplicated. And so inside of df duplicated, you're going to want to do subset, and this is similar to a function that we had earlier where we had to do a subset. I forget which one it was specifically, but and then now you're going to want to pick which columns that you want the subset to be of. So for this example, I'm going to just check math, reading, and writing score because I want to see all the students with all three of the same scores at the same time. I'm going to keep on accidentally doing that. There you go. Let me comma. I'm just gonna just copy these. Just copy it like this. There you go. That works. And so now if I run that, this is going to be, as you can see, there's 10,000 rows, which makes sense. There's going to be a lot of students with the same exact math, reading, and writing score in comparison to the 102 rows, where they have all of these matching feature types. But anyways, so that's how one way to check duplicates of a specific subset. And just for an example, for this one, I'm going to show you how to drop um, let's say this first example right here. So 71, 71, 74. Any students with this matching these matching scores, I want to take out of my data set for whatever reason. So let's just do that. So the way we do that is do df.query. This is a new function. And so this one is going to run a query similar to like an if statement, but now it's going to be reading stuff from your data set. So what we're going to do is where math score, oops, here, let me do this. Math score is equal to 71, like I said. And then we're going to want to do an and. Reading score is equal to 71. And writing score is equal to 74. Okay, so we're going to query all of those really quickly. And if we run that, we're going to see these three rows, row 0, um, 71, and 5500 have 71, 71, 74 as their math, reading, and writing score. So this is a cool way to query specific rows within a data set that you maybe want to know how a specific value or multiple specific values. That's one way to do it. And so the way that we would drop these is we would take this, copy it really quickly, and let me do this real quick so you guys can see the shape before. As you can see, we have 26069. And so make sure to copy this and do df is equal to df.drop. And then inside of this parenthesis, we're going to want to do the df query, paste it in there. but don't just do that, do dot index because now we're going to be pulling the specific indexes that we need to drop, which is what the drop function needs. And then now we run that, and now if we do df.shape, we can now see that we dropped those three rows. As you can see, went from 26069 to 26066. Um, so that's one cool thing you could do. There's a lot of ways to check duplicates and drop specific duplicates of stuff. But query and dot duplicated are the most popular ways. And so I would say that's pretty important to understand. And so now we're on to step three, which is feature understanding. Um, Now that we've kind of cleaned up the data set from duplicates, from NA, or sorry, missing values, which let me tell you, we didn't fix all the missing values. If you guys remember up here, we saw, how far back is that? Here we go. Is NA sum? We saw that there's still a ton of missing values in test prep, practice support, is first child. If you were actually cleaning a data set, you would address all of these in some way and have a plan to attack all of them. But just for the sake of time, we're already over an hour here. It would take a long time to do all of that. So we're gonna just move on. Now, let's say we've cleaned our data set. Um, Now we want to try to understand features. And now this is also going to be called univariate analysis because basically we're going to start visualizing singular features. So let me show you guys how to do that. Um, so the A good way to do this through pandas actually is go df and then let's visualize number siblings first, right? Because we've been doing a lot of stuff with that already. And so this function called dot value counts um do that and then run that really quickly. So this will take the value counts for every number sibling, right? Um so and it's going to do them in decreasing order as it has here. Basically, let me explain that really quickly. Everyone with one sibling, there's 82,000 children in the database with one sibling. There's 6,790 with two siblings, and then so on and so forth for 3, 0, 4, 5, 6, 7. And as you can see, the reason it's not going from 0 to 7 is because it's going in decreasing order. So there's actually a higher chance that you have three siblings than zero siblings, according to our data set. So dot value counts is pretty cool to run on a lot of different features inside of the data set to kind of get an understanding of how many people in the data set have a singular feature. And so if we go down here, we want to try to plot this into some type of distribution. So if we do df dot value counts, and I'm just gonna stick it right there and do dot plot. Um, and do what kind of plot? We're going to do a bar plot, and this actually has to be in quotes. And then the title we're going to have here is going to be most popular number of siblings, right? And so if we run this, as you can see, it's been plotted. And I actually think that this would be better as a horizontal plot. So uh, we could do bar H to see it as a horizontal plot. And there we go. Um, as you can see, we have the number of siblings and the basically the frequency on the bottom. And actually, the way we should really be doing this is we should be setting it as an axis or like as a specific variable because as you can see this is the data type of what we just created. It creates a matplotlib object actually. Um, and so we're gonna name that object ax for axes, and now we can do specific things oops to this data type or like this data type this object by doing stuff like ax.set x x label. Um, and we could do the X label will do count and then ax dot set Y label and have this label be number of siblings, right? And now if we run this, as you can see, it changed the X and then the Y. And so this is all under like the ax object, which is pretty cool. And I would say, for whenever you're visualizing your data, I would always recommend that you put a title and set an X and a Y label if they're not already there. I would say it's the very bare minimum to kind of give users an idea of what you're actually visualizing. Maybe you know what you're visualizing just from the code, but a lot of people often don't. So definitely try to do that. So that's pretty cool. We kind of visualize the number of siblings. So now let's do it for like other parts of the data set. So if I go to df.columns real quick and see the other features in the data set, let's do it for math score now. And so we're going to do ax is equal to df and then math score. And then we're going to do dot plot actually. And then this kind of plot, what we're going to want to do is a histogram. So the way we do that is kind hist. And for a histogram, you're going to need to select a number of bins. So for this one, we'll do 20 bins. And then we're going to want to put a title really quickly. And so this is going to be math test scores. And if we just run that raw, there you go. You can see the histogram of the math test scores. As you can see, it seems like the average is around this like 65, 70-ish point, and it follows a somewhat normal distribution, centered around that, which is pretty cool. And then obviously you could set X labels. I would say it's pretty important to do that, just so people know what's actually going on. So do set X label, and then we'll do math scores, and then percentage. Okay, so run that, see the math scores percentage. Cool. And then I also wanted to show you guys another type of visualization that we could have here. And this one is most powerful for like a continuous values. So math score, I wouldn't say is really continuous because they all have to be solid integers. But and they all range from 0 to 100. But you could still plot it as a continuous value. And then we do KDE, which is its density graph, basically. And so with this, all we have to do is kind KDE and then do title again is equal to math test scores. And if I run that without setting the title, as you can see, there's the density function for it, and it kind of matches the flow that we kind of had here for the histogram, for the density function. But as you can see, it's kind of weird because it doesn't get cut off at 100 necessarily. And then now it has values like 125, 150 when none of the values in our test scores go that high. And now it's even showing negative values. So, a way to get a cleaner density plot is actually to use a seaborn. And so the way we do that is we do sns.kde plot and then df math scores or math, yeah. Is it math scores or score? Score. There we go. And then if we do plot.show and run that really quickly, there you go. This gives you a better idea of the density, and it's a lot cleaner than I would say here. Um, and this is using seaborn, which is a another way to visualize data. And whenever you do a seaborn plot, it will also turn it into a matplot object. And so the way that we run matplot objects is with pld.show. This is actually not necessary. If I just ran this straight up, it would give us the same thing. But then now we have this ugly identifier of what type the object type is. So plot.show basically gets rid of that for us and makes it a little bit cleaner. Um, but plot.show is what you're going to want to do to basically show off your visualizations at the end of everything. And so that's a better looking KDE plot. And say you do want to set a limit to like 100 and to 0, because as you can see, it seems like they go over a little bit. You could do that by doing plt.xlim, and you do that from 0 to I would say 101, because if you do that at 100, it kind of gets cut off kind of weird. Let me show you. It looks like it hangs off the edge. So if we go like 101, that gives us a better idea. Again, it still kind of looks like it's hanging there. But um, you know, that's what you could do if you want to limit the x-axis. So, what I did for math score and for number of siblings, I would do this for all of the features of my data set if I was really doing a full exploratory data analysis. But for today, just for the sake of time, I'm not going to do it for everything. This should give you a general idea of how to visualize every singular feature. But now we want to look at some feature relationships. So how features correlate with each other. So let me do that. So let me go again back to df.columns, run that, and you can see the columns that we have here. And so the first thing we're going to want to plot is a scatter plot. So we're going to do kind, and also just a quick tip really quickly. Whenever you're inside of a function like this, you do Shift Tab. Um, it'll give you what you could actually put inside of the function. I think me even doing like that. There you go. It kind of gives you the function description, makes plot of series or data frame. And if I did it up here to KDE plot, for example, it'll tell you all the different variables that you could insert. You could do change the color around, do stuff like that. So that's Shift Tab, okay? I just want to make that clear. So, anyways, we're gonna do df.plot, and we're gonna do kind is equal to scatter. And I think if I do Shift Tab right here, it actually tells me what kinds I could. Oh no, it doesn't. Okay, anyways, kind scatter, and then on the x-axis, we're gonna let's compare the reading scores and writing scores because I bet you those are pretty correlated. Usually, if you're a good reader, you're a good writer, I would say. And so let's do x is equal to reading score, and y is equal to writing score. And then let's do title of this is going to be reading versus writing scores. And if we run that really quickly, let me actually do plot.show or plt.show. So we get rid of that weird object. There we go. So you could see the reading writing scores they almost look like linearly coordinated. Or correlated, I mean. As you can see, they go in like this straight line straight up to the right. But with all of the data points that we have, this is actually like really hard to read. I'll be honest. You just look at this and you just see a splotch of blue. So one way we could do that especially for bigger data sets, to improve that, is that we do df, like what we did earlier, dot sample, and then we pick a number. So say I only want to show 250 data points, and then we run this. Now that gives us a better visualization that's actually, readable. And it's still, you can still tell that it's pretty linearly correlated. Um, but that gives you a better idea of um, uh, how the writing and reading scores are correlated in comparison to that blob that was there a second ago. Um, and so that's just one tip that I would have. Another way to do a scatter plot, and this one's actually better in my opinion, is through seaborn. And so the way that you would do that is you do ax is equal, and you could do it any variable name, but I like to do ax for the axes. And so you do SNS dot scatter plot, and again you do x is equal to reading score, and then y is equal to writing score. Oops, writing score. And then we actually have to add a data here because our data frame isn't automatically connected to it. So we data is equal to df. And then again, um, or actually we do it outside. We do ax dot set title, and I think you could set it inside as well. But this is another way to set the title as outside. And the reading score versus writing score. And then we'll do a quick plt dot show. And this is a better visualization. Again, df, it's too hectic. So let's do df.sample 500. It gives you a better idea. But the cool thing, you're probably like, okay, this is literally the same thing that we did up here. But the cool thing is you could add other stuff to Seaborn scatter plots. So now let me add hue in here. And so you could do hue is equal to, and let me pick a random variable. What should I do? Let's say weekly study hours. We haven't looked at that too much. So Hugh's weekly study hours, and make sure to add a comma at the end right here. Um, and as you can see, now the weekly study hours are also shown as different colored dots. So not only are we seeing the reading and writing score and their correlation, we're also seeing the correlation of this other variable, which is super cool. Um, just looking at this, it doesn't look like honestly how much they study really matters. There's like I would say the same amount of green, orange, and blue spread across everything pretty equally. Um, so you know, I guess studying more doesn't really help, but it's cool to look at. And so that's one cool feature with Seaborn that I would definitely take note of. So I would say that's it for like the scatter plots. Um, a good way to visualize a bunch of your data together is through something called a pair plot. And so let me do one of those for you right now. So SNS dot pair plot. And then again, we're gonna throw in our data frame, but we're gonna do sample 100 to make it a little bit easier. And now this is gonna come with some vars. And now basically this is where we choose um, which variables that we want to put into it. So pair plots work a lot better with numerical values, and a lot of this correlation stuff and feature relationships work better with numerical values. And I'm going to show you why in just a second right here. But I'm going to take the math score, the reading score, put them down here really quickly. And actually, I could do df dot um, columns down here, so I don't have to keep on scrolling up. And then I'm also going to throw in the writing score as another thing. And then just to show you a non-numerical value associated with this, we'll do is first child. Okay, so let me throw that in there. Um, and then we do plt dot show. If I show that, I might have to zoom out here. It's just taking a second to load. There we go. And let me zoom out actually so you guys can have a better view. So basically, it turned all of the given variables within this data frame that was given to it into X's and Y's, and you could actually see the correlation between all of them this way, which is pretty useful, I would say. So for example, if I want to look at the math score and writing score correlation, there's the plot map. Um, if we say math score and math score, actually, this will just show you kind of like what we had earlier, a histogram of the distribution. Um, so it's still pretty useful. Um, and as you can see, a lot of these numerical ones, like reading score and math score, they're visualized pretty well. But then we have like these weird straight lines. And so what's that? That's when we take like a categorical value. So what it tries to do when you give it a categorical value with like a numerical value is it kind of changes it into like these yes, nos, and then it still plots them as little dots. And so these are less interpretable. um, they're still pretty like you could still interpret them. For example, if we go to is first child on the axis and then reading score on the y-axis, it kind of looks like if you aren't a first child, you're a little bit denser up here and like there's less bad scores, it kind of looks like reading scores. So it's still interpretable, but it's hard to interpret categorical values with this pair plot. But this is really good to do with all your numerical values all at once. So you can kind of just like have it all in one spot and see like if anything major really pops out at you. Um, and so that's one pretty cool thing that I wanted to share with you guys is the pair plot. And the final thing I'm going to show you guys is the correlations between features. So, so the way we look at the correlations is I'm going to make a variable here called df4. And I don't know if you guys can see my screen well. I'm going to zoom in back up to 100% here. Um, we're going to do df core is equal to, and then df, and then we have to do double bracket here. And then this is where we put all of our numerical values that we want to see. So correlation only works for numerical values. Let me point that out real quickly right now. So we only throw those in there. So let me do that really quickly. Do the writing score, and I think there's one more numerical. I think technically number of siblings is a numerical value. And so we could throw that in there as well. And put a comma there. And so after you put in the specific ones in the data frame, you do dot drop NA because this isn't gonna work if you have any missing values in these areas. So you're going to want to do drop NA if you, and usually you wouldn't have to run drop NA if you've already cleaned your data set. But for our example today, we didn't do that all the way. So we're going to stop some in there. So we're going to want to do that and then do dot core with two R's. And if I just do df core after this, as you can see, this is going to give us like a cool little correlation map. Um, and so as you can see, some things have positive correlations. It seems to be like a heavy positive correlation between writing score and reading score, which is cool. And even a positive correlation with math score and reading score and math score and writing score. There actually seems to be negative correlations between the numbers of siblings you have and your test scores. So if you guys have multiple siblings and you get bad test scores, you could blame it on them. But that's pretty funny. But a better way to visualize this is actually through a heat map. So if we do sns.heatmap and then we throw in that df correlation table that we just outputted, um, and then we do plot.show we can actually visualize it like this. So as you can see, it'll go from 0 to 1 for correlation. Um, and the darker stuff is obviously at the bottom, and then the lighter stuff is at the top. And so you can kind of visualize it in this way. And this is I really do like it like this because it gives you like a good idea just all at once of what you're looking at instead of going value by value and trying to understand that. And actually, one flaw I would say with this is that we don't actually see the numerical values associated with all of these, but you can actually change that by going into your heat map and going to annot, which for annotation, and then doing true. And if we do that, now we have the numerical values that pop up for them. And so this is a lot better to look at, in my opinion. You get to actually see just off of heat and also the numbers of correlation that there are. Um, and so, yeah, this is definitely one of the best ways to look at your feature correlations for numerical features. This is really interpretable, and you could see like what has the highest impacts and like the lowest correlations. Um, so yeah, and I think that is about the end of our step number 4 section. And I know I'm way over like an hour 30, but there was actually no real hour time limit to this one. So there's no problem. But so that wraps up our feature relationships. And now we're on to the last step, which is step number 5. And this is where you're going to want to ask a question about the data. So as you can see, we've just been like looking at the data, we've been visualizing, we cleaned it up, we got rid of like null value, stuff like that. We visualized singular features, and now we visualized how features interact with each other. And now at the end, what's the whole point of this if we can't use it to answer a question that we have about the data? So, um, I would say this is one of the most important parts of like an EDA, especially if you're like interested in those data analyst roles, is that they're going to be looking to you to ask questions about the data and also answer them in your code. Um, and so this is kind of expected. And so I just have an example question here, but as you can see, ask a question about the data. Try to answer a question you have about the data using a plot or statistic. Don't just like just like, oh yeah, just from what I saw, like obviously this stuff is like linearly correlated. There's ways to visualize that we can see here. But I'm saying like maybe you're just looking at like a df.head, and I don't even know when our last one was. Like, don't just go off of here and be like, oh okay, it seems like most of the scores are around like the 65, 70 mark. You know, um, actually try to visualize the data. And if you're interested in those data analyst and data scientist roles, this is like popular like interview question style questions that they'll give you on the spot they'll give you a data set and then they'll tell you like they'll ask you a question about it and they expect you to know how to answer through visualizations or a statistic um, and so let me show you guys how to do that really quickly just with one example and obviously this is kind of like the hardest part of this because it kind of changes depending on the question but as you get more comfortable with pandas you'll see that it's really not that bad, and a lot of the functions with pandas are pretty intuitive. Um, and so the question I have here is what are your average test scores if you have four plus siblings? I want to try to visualize that through um, our data. So how are we going to do that? Let me just jump straight in here. So um, we would do that, but first we're gonna set an axis, or actually, well, we'll save that to the end. So first we want to do df.query. And so what is a query going to be? Well, we want the query to include everything where the number of siblings is greater than or equal to four, right? Because if you have four plus siblings, so pretty obvious. And so from there, we want to group by, and so this is the group by function. Um, I don't want to go. If you guys are familiar with SQL, you probably already know what group by is. But basically, what this does is it groups up the data given a specific parameter. If you're interested in what this really does, I'm just going to go through the answer today, and you could go in and like look at a Panda tutorial yourself if you're interested about what a lot of these functions do. But group by, well, what we're going to do is we're going to group by the number of siblings, right? So now it's going to be in groups of depending on how many numbers of siblings you have. So everything where the number of siblings is four, five, six, seven, they're all going to be grouped together. And after we group by the number of siblings, we're going to actually want to look specifically at the math score, um, the writing score, and the reading score for these groups because we're asking what the average test scores are. And so these are the three test scores in our database. And so from here, we're going to do a dot aggregate function. And again, if you're familiar with SQL, you'll already know what this means. I'm not going to explain what an aggregate is right now. But basically, we could use an aggregate function to get the mean from these scores, which is really cool. So we aggregate them into a mean. Um, and then from there, we it seems like we have everything that we need. So we grouped them all by the number of siblings, and then we got their test scores, and then now we got the average of those test scores with mean. So I think we're ready to plot now. So we'll do slash plot. And actually, to make this a little more visually pleasing, there's one thing I could do for you guys. Um, if I go like this, and then like this, and then like this. Oops, dot plot. There we go. Basically all I did is I split it up with these backslashes. It'll still run the same, but now you can see everything in a straight line. Um, so now we're gonna plot, um, and the kind of plot we want here is a bar plot. I personally like the bar horizontal plots better, so I'm just gonna go with that. And then here I'm gonna set the figure size to 10 by 10 because it's gonna output weird at first, and actually I'll wait to do that till after so you guys can see. Um, but and then we'll do a title. So this is going to be the average test scores with four plus siblings. All right. And if I'm not wrong, that should be everything. And then at the bottom here, we're going to want to do, okay, we're going to want to set this to an axis of first. We're going to set it to a specific variable. And then we're going to do plot dot show, plt.show. And if you run that really quickly, there we go. We could see the different test scores. So now this is actually kind of hard to look at and understand, but we can see from 0 to 70 test score. Here are the test scores for depending on how many number of siblings are and the averages. But I actually want to be able to visualize this a little bit better and actually have the numbers of the means there. So how I do that actually is now that we have this axis as a specific variable type, we could do something called like or by we could do something in a for loop, and I'm gonna do for container in oops in ax dot containers. Um, we're gonna do ax dot bar label, and then we're gonna throw the container in there. And so basically, what this is gonna do is it's gonna take every one of these containers and it's gonna label them with what the container value is. And so if I run that really quickly, as you guys can see, it'll have the percentages or the averages of each test score, depending on how many siblings you have. And so that's pretty cool. And let me just clean this up a little bit. Like I said, the figure size is kind of weird here, so everything is kind of squished together. So that's why I went with a figure size of is equal to 10 by 10. And then there's also some other things I want to do to clean this up. For example, this legend, for some reason, the title is none, comma none. I don't know why, but we could change that really quickly. So we could do legend title is equal to, and we'll do the test types because that's what they are. Um, and then we want to set an X and Y label. So we'll do set X label. And so these labels are going to be the test score percentages from 0 to 100. Um, and so let me put that down really quickly. And then these Y labels, I'll set Y labels. This is going to be the number of siblings, right? I think that should be everything. So if I run this again really quickly, as you can see, since I put the figure size to 10 by 10, it's a lot bigger, a lot easier to look at, in my opinion. If I do control minus a couple times so you guys can see the whole thing. Oh, for some reason I put a little thing there. Let me fix that. And so now the legend is titled correctly. We have X and Y labels. And now we visualize the question, what are your average test scores if you have four plus siblings, right? And now you can see. So uh, for reading scores, they seem to be higher than most other scores when you have a higher number of siblings in comparison to like your math score. Um, which is pretty funny. And that might just be not really a correlation between the number of siblings and test scores, but maybe just the average test score is lower across the board, and so our average math test score is lower across the board in comparison to like the reading test scores. But as you can see, we visualized that question. And that might have been kind of confusing, especially if you're kind of new to Python and pandas. A lot of these functions might be kind of new to you. But trust me, the more you get comfortable with these data sets, the more you're going to be visualizing this stuff, and the more it's going to make sense to you. And this stuff will start coming naturally. Um, but yeah. And so that's us visualizing a question. And obviously, it's good to ask multiple questions. We don't have the time for that today. So we're just going to be focusing on this one question. Um, and that about wraps it up for the exploratory data analysis. So a really quick wrap up. I know that was pretty long today, and I know we had some hiccups, especially at the start, when it came to like actually getting loading the data frame, for some reason. But as you can see, we imported the data. We did a quick df.head, and then we did some stuff to try to understand the data, which was a lot of these different functions, df.shape, head, sample, tail, uh, and then the data types and the columns, and then this describe to try to understand what we're actually looking at. And then we did some stuff to prepare the data by dropping unnecessary columns or dropping columns that we just didn't think that we would want to use. And then we replaced missing values for number of siblings. We looked at duplicate data types, or duplicate rows, sorry. And we also, or actually, let me go to where we did that. That's down here. Well, we renamed. So we looked at duplicate rows. We renamed some columns. Um, we also changed the numeric types from float to integer for number of siblings for to something that makes sense. And then here's some recommendations for I would say to keep. Um, and so we did all of that to kind of clean up our data set. And then from there, we tried to understand our features through some different visualizations, histograms, KDEs. Um, we actually didn't go over a box plot, and yeah, I didn't go over that. So I might want to do that really quickly, actually. Um, so if I go to df dot plot, kind is equal to box plot. If I just do that really quickly, oh, it's just box, not box plot. There we go. So this is what a box plot is. I forgot to do this earlier, sorry. So if you do the box plot of your entire data frame, it's going to take all the numerical values, and this will basically show you the mean, the interquartile range, and I think this is like within like that 25% to 75% range. And then this is basically a good way to identify some outliers. So for our math score, reading score, writing score, we don't really have any serious outliers. I would say maybe these data points of these people getting really bad scores. Um, but for the most part, it was pretty normally distributed between 0 and 100, with just a skew a little bit to the 70 percentage area. But this will give you a good idea of outliers and a quick visualization. So I forgot to go over that earlier. Sorry about that. And then we went over how to look at some feature relationships with scatter plots, how you could do multiple with hue and seaborn, which was super cool. And then pair plots to give you a visualization of a bunch of your data all at once. Um, and then how to look at the correlation for your numerical values was all here too, and how to make a heat map out of that, which was super cool. And then finally, how to ask a question about the data and to try to answer that question with the data you're given. Um, so that gives you like a pretty rough idea of what to do when you're doing a exploratory data analysis. I know that took a little bit longer, but I really try to take my time explaining a lot of stuff, assuming that you guys didn't know that much. Um, but as you guys keep on doing this, this is really going to become second nature. You're going to be looking at stuff. You're going to jump straight to the missing values, fix those, jump into the duplicates, see if there's anything that doesn't make sense there. So this is really something that just gets better with time. And I would definitely say try this for a different data set. And also, I would also look into other ways to analyze your data set because I didn't go over all of them, obviously. There's a lot more you could do in an exploratory data analysis. And actually, what we went over today was, I would say, the bare minimum that you have to do to analyze your data. And so I would also look at other ways you can analyze your data. But yeah, so that's basically what an EDA is. And after the EDA, to try to get you guys more comfortable with incorporating this into the data science lifecycle. After the EDA, what you would usually do is, now that we've cleaned our data, we're gonna put them into split, or we're gonna put them into test and training sets, and then we're also gonna be trying to handle imbalanced data if necessary. Like for example, if any of our data is too skewed, we're gonna want to try to fix that. And we're gonna start deciding on feature selection methods for models, and there's a bunch of ways to select features for models. And we're actually gonna talk about that more in the coming days, with supervised, unsupervised, and vision learning. Um, but yeah, so that's what you do right after an EDA. But I think that wraps it up for today. So let me make sure there's nothing I'm forgetting. Let me look at my notes really quickly. I think that is everything. So let me just go back to this slideshow really quickly. And so I want to thank you guys so much for sticking around, especially to the people in the Zoom, and trying to do that alongside with me. I really do appreciate it, and keeping me company today. And I know this was probably longer than some of you might have expected, but that's just how it goes sometimes. And we didn't want to put any time limit on the workshops this week. Um, so I hope that was pretty useful to you guys. And so for the upcoming days, tomorrow, it's actually not going to be me hosting the workshop. It's going to be our tech lead Sarush, and he's going to be going over supervised models. So if that interests you and you want to understand how to prepare your data specifically for supervised models and how to train them, he's going to be walking you through that tomorrow. And then I'll be back on Wednesday with the unsupervised models. And then on Thursday, Sarush is going to be going over vision models. And then Friday, I'll be wrapping up the workshop series with a little demonstration of how to win AI data, which will basically be going through how to talk out your thought process when you're making these data science projects. Um, so yeah, that's everything for me for today. So again, thank you guys so much for sticking around. I really do appreciate it and keeping me company through this long workshop. And I'm gonna be posting this later. So if you guys missed anything, or I went a little bit too fast, or maybe the code wasn't working for you for whatever reason, feel free to go back and try it again later. I'm gonna try to get it posted by tonight. But it's a longer video, so we'll see how that goes. But yeah, so if you guys want to stick around, feel free to. I'll stay back and answer any questions. But if not, you guys are free to leave, and you guys have a great rest of your nights. Okay? Thank you guys. Of course, yeah, no problem.
Is that okay? We can go back to the df.drop. I don't
Yeah.
I was able to like, because right after that, I can't manage to
I see.
follow along. I'm assuming I can't really do follow along the majority of what happens after because of that. I don't know why.
Yeah. Yeah, that's really weird. Actually, do you mind sharing your screen for that so I could
Yeah,
see?
sure, sure.
Yeah, let me. I think I have to give you permission.
Send request. Okay.
Yeah, let me do that. Wow.
Okay.
Uh,
Can I share?
yeah, I think so. Try it again.
Okay, then. Share. All right. Sorry if it's a bit hard to see.
No, it's okay. It's fine. Okay, so df drops dot columns. And so what's the error? Scroll down to the bottom really quickly.
Key error. Let's see here.
Yeah, it's a key error. Go down to the very, very bottom of the unnamed, not found in access. Okay, wait, go back
That's
up.
the
So
thing. I was, what the? It was there for a minute. Hold
yeah,
up.
so I think okay, I think this is what happened. So I think what happened is you like just add like an extra code to like I don't know. I just run df.column somewhere. Like just run that yeah, just anywhere. Or run the df columns one specifically.
Oh, shoot.
No, not that, not that. Run the you see the one right above that? Df columns.
Yeah.
Run df.columns. Oh wait, don't paste that. Sorry. Here, I'll put it in the chat. Run this columns.
So it's
Mhm.
just df.columns.
Yeah, yeah, yeah. Just run df.columns.
Got that?
Yeah, there we go. And so as you can see, it's not there anymore. I think what happened was either you didn't notice or um it gave you an error and then it worked, but you couldn't really tell. Uh because what's happening is whenever you run that code again, it's trying to drop that, but now it's checking your current data frame and it's showing you or telling you that there's no column called unnamed anymore. So if you actually do like a df.head really quickly, it won't be there anymore.
All right. Df.head.
And then do the parentheses around it, like the yeah, like that. There you go. And so as you can see, the unnamed value isn't there, unnamed zero. And somewhere along the line, you probably dropped it, but didn't really notice. And then you try to run it again, and so it started giving you that error because it's like, oh, well, your current data frame doesn't include that anymore. You kind of get what I'm saying?
Yeah, okay. So it's just a
Yeah.
matter of order of things that messed.
Yeah, like if you run drop twice in a row, it's not gonna work. It's only gonna work the first time because after it drops the first time, when it checks for those columns again, it's gonna be like, well, that column doesn't exist anymore, and I never knew it or I never knew it existed because it's only realizing what the current data frame is. So
So all I have to do is be careful on what type of df dot tail dot shape, like what order I have to put in or what code I have to put after, and that's it.
well, I would say so, especially like this when you're looking at the df.tail and head at the top, it's kind of misleading because it shows the unnamed zero column. But it's actually not there anymore because this is old cell. So if you run that current cell again, it's gonna disappear because you've already dropped those columns. So I would just say just be careful and make sure you're keeping track of your current data frame when you're doing stuff. Like I would say if you're not sure what your current data frame has, run either df.columns, df.head to see if what you're trying to drop or what you're trying to add is already there or what you're trying to drop is already missing. Um, I would say just to be careful of those things because it's pretty easy to like get lost in that way.
Oh
Um,
my gosh. All right then.
yeah.
Well, looks like I have a lot of catching up to do, but at least I kind of understand.
Yeah, of course. And I mean, like showing up to this workshop is really good. Are you, by any chance, like, are you newer to Python or are you CS major? You were at our meeting earlier, right? You're one of the mentees.
Yes. I actually
Yeah.
took a Python course,
Oh,
but
did
I'm
you?
not really good at coding, if I'm being quite honest.
I mean, yeah, that's completely fair. So like a lot of this stuff might be kind of diving into the deep end because a lot of this is like really abstracted from like the normal like Python code and like stuff. But like once you get comfortable with like pandas, and that starts to become like your favorite reference, I think you'll start picking up pretty quickly. But yeah, for now it's kind of like a slow start. But like showing up to workshops like this is like a great way to get ahead. And then I would say if I would definitely like look online on YouTube or something, just a quick like the 20-30 minute pandas tutorial, and that'll give you a really good foundation of what you're actually doing with pandas, and it'll cover over a lot of the stuff like the df.drop and why those errors are popping up a lot better than I did because we never really did like a pandas workshop. We kind of just jumped into this one, assuming you guys already knew what pandas was and you guys are super familiar with it. But I would definitely try doing that to try to brush up on some of the basics with that again. And then from there, I think you'll probably be fine.
All right, so look up at 20 to 30 minutes of pandas. I got it. And
Yeah.
regarding back to the error, the gist of it is making sure I have consistent data. It's basically whatever data I have previously must be consistent to what I have, because at least the best way I can explain back from the thing, like the unnamed. Can you
Mhm.
explain that again?
Yeah, so what was happening was if you go back to like the drop command that you had, what you were doing when you ran that drop command was you were dropping a df.drop and then columns and then the column name that you wanted to drop. Um, but your current data frame didn't have that column name anymore. So whenever it tried to run that command, it looked for the your columns and it threw out an error, a key error because the key that you gave it, which was the column name, doesn't exist. Um, so all that really meant is that the column name obviously existed before, but at one point when you ran it, it dropped successfully, but you probably just didn't notice or it wasn't really obvious. And so you try to run it again, and then that error popped up because the column was already gone.
I see. Got it.
Yeah. Yeah.
Well, man.
But yeah, it's no problem. I mean, it wasn't really like a big error. If you try to follow along with the rest of the stuff we did today, um, you it probably it was like it was more so of like an error of knowing that it was already dropped instead of like pandas not working or your data frame wasn't readable or something.
Mm,
So it wasn't really like a huge deal. I'll be honest.
I see.
Yeah.
All right then. Thank you, Sean.
Yeah, no problem. And hopefully, I'll see you in the upcoming workshops.
All right. Thank you. Have a good night.
You too.